You might have heard about the Ohm's law. This is actually the correlation between the voltage and the current within a circuit, right? Ohm's law was probably the most important of the earlier quantitative description of the physics of the electricity. We know the mathematical conclusion of the Ohm's law that V is equivalent to Ri, where each and every term has their usual meaning. V represents the potential difference across the conductor, where R represents the resistance which is constant, and I represents the current flowing through the conductor, right? Now we will discuss Ohm's law in a brief description. Okay, let's start. Now the question arises that who gave Ohm's law and what Ohm's law states, right? Ohm's law was given by the German physicist George Simon Ohm. He stated that the electric current flowing through a conductor is directly proportional to the potential difference across its ends, provided its temperature remains the same. That means Ohm's law is applicable at the constant temperature. This is commonly known as the Ohm's law. Now let us verify Ohm's law experimentally. The experimental setup to verify Ohm's law comprises of nichrome wire of 0.5 meter, that is a piece of resistance wire, a milliammeter to measure the magnitude of the current. You can also take the ammeter. Number third apparatus is switch. Number fourth apparatus is the voltmeter that is used to measure the magnitude of the potential difference. And the fifth apparatus required is a cell of 1.5 volt. Here we are taking a cell of 1.5 volt. You can take the cell of less or more potential difference. It is up to you. Okay. For the experimental setup, we are going to connect the cell with number 1 nichrome wire, number 2 milliammeter, and number 3 voltmeter. What we will observe? Keep watching. On pressing the switch, a current starts flowing in a whole circuit, including the conductor, that is nichrome wire. This current is shown by the milliammeter. For one cell of 1.5 volt, the milliammeter gives the reading of 120 microampere, that is 0.12 ampere. And the potential difference on the voltmeter gives the reading of 0.3 volt. That means for a cell of 1.5 ampere, the current measured is 120 microampere or 0.12 ampere, and the potential difference is 0.3 volt. Okay. Now for the second time, if we are going to connect the two cells each of 1.5 volt, on pressing the switch, same phenomenon repeats. That means current begin to flow through the circuit and also through the conductor, that is nichrome wire. What we will observe, that the ammeter gives the reading of 200 microampere or 0.2 ampere, and the potential difference measured in a voltmeter is 0.5 volt. Okay, so for the third case, when we connect three cells each of 1.5 volt in a circuit, the current begins to flow. What we observe this time, right? The ammeter measures 300 microampere or 0.3 ampere of the current, while the voltmeter measures a potential difference of 0.75 volt. Okay. Now let us tabulate the whole reading that we observe in the three cases in the form of a table. So we are required of the 4 columns. The first column is for the number of the cells. So in the first case we take 1 cell, in the second case we take 2 cells, in the third case we take 3 cells. The first column is for the number of the cells. Okay. The second column, it is for the measure of the current I in terms of the ampere. And the third column, that is for the potential difference across the conductor. Here we are taking the nichrome wire as a conductor. It is in terms of the volt. And the fourth column is for the ratio of voltage to current, that is V is to I. That remains constant throughout. So we can conclude that the voltage is directly proportional to the current. That is, with the increase in one physical quantity, there leads to the increase in another physical quantity, and vice versa. In this way, Ohm's law is verified. Okay, so Ohm's law is verified. Okay, now we will discuss Ohm's law in terms of VI graph, where V stands for the potential difference and I stands for the current flowing in a conductor. If we draw a graph between the potential difference reading V along x-axis, that is abscissa of a Cartesian coordinate, and corresponding current value I, that is ordinate along y-axis, the graph is found to be a straight line passing through the origin, right? Okay. So we know that in order to plot a graph in the Cartesian coordinate, minimum 2 points are required. But here we are taking 3 points to avoid the error and to be a more accurate, right? So you can observe that the graph is a straight line that passes through the origin. Hence we can conclude that V is proportional to I. V, that is the potential difference, is proportional to I, that is the current, as the ratio of V is to I is constant. Here the proportionality constant R is known as the resistance of a metallic wire at its given temperature. Hence V is to I is equivalent to R. So the mathematical form of the Ohm's law is V is equivalent to I R.